Okay, and then once we finish going over these problems, there's a few problems for you guys to practice on Delta Math, just on your own, and then we'll go from there. All right. All right, so the first couple we're going to look at are factoring greatest common factor and also factor by grouping. So normally we spend a little bit of time in first semester factoring, but just with the shortened schedules and everything, we kind of cut that out. So I want to make sure that we take a look a little bit at factoring, since it's been a little while since you guys have done it. So the first one is factoring the greatest common factor or factoring by grouping. If you want to write these down, you can. If you just want to listen, you can. Remember on Delta Math, there's explanations and there's videos on there as well. So if you just want to, like, if you don't want to take the notes and you want to look at them, then on Delta Math, that's fine as well. Right. So greatest common factor. Basically, what we're doing is we're looking at all of the different terms. Okay. And so remember, terms are separated by addition and subtraction. So here we have 3 terms, and we're looking for something that can be divided into all 3 of those that is the same, right? Something in common that we can divide all 3. And so when we look at, first off, we look at the coefficients. I've got 8, 2, and 16. Okay. I know that I can divide each of those by 2. All right, so that's part of my greatest common factor. When we look at the x's, right, in order to divide exponents, we are subtracting them. So I'm looking for the greatest exponent that we can subtract that they all have in common, right? And so because of the second term, we can only subtract 1x away. I have an x in my GCF. All right, in the y's, I've got y2, y5, and y3. The greatest that I can subtract, okay, would be 2. So my GCF is 2xy squared. Right. So when I factor that out, I'm going to write my GCF out front. Okay, and then we're going to divide each of those terms. So 8 divided by 2 is 4. X4 divided by x is x3. Y2 divided by y2. That becomes 1, and so we don't necessarily have to write that. They just cancel out. And then we're going to do -2 divided by 2, which is a -1. Which, because we're going to have, anytime you have a coefficient of 1, unless both the x's and the y's canceled, you don't necessarily have to write the 1. So the 2's are going to cancel, the x's are going to cancel, and when I simplify my y, I get y to the 3rd. And the last one, 16 divided by 2 is 8. Y3 divided by x, or sorry, x3 divided by x is x squared. Y3 divided by y squared is y. All right, and so that's your answer. All we're doing when we are factoring, okay, is we're taking a larger expression and we are trying to break it up into more manageable expressions, right? And it's super helpful when we go to actually try to solve these types of equations. But like right now, we're just factoring. All right. Now, a lot of times when we have 4 terms, there's no good traditional method to factor. However, sometimes we can factor by grouping. So here we have 4 terms. And to factor by grouping, what we do is we break this into 2 groups, okay? And we look for the greatest common factor in each of the groups. So if I have x to the 3rd and x to the 2nd, what can you take away from both of those? You can take away x to the 2nd. So when I take that away, I have an x and a +1 left over. Here, there's not necessarily anything in common, but both of them are negative. And so I'm going to take a -1 away. And so when I divide -x by -1, I get x. And I divide -1 by -1, we get a +1. The only time factoring by grouping works, okay, is when you have that common remainder after you factor out that GCF. Okay, so here where we have the x +1, we can now factor to say x squared -1 and x +1. Okay, now, because of, if you notice, after we factor this out, we can actually factor this further. Because here we still have a quadratic expression, both of which are perfect squares, and we're subtracting. So this, we can actually factor to x +1 and x -1. And then we bring down the other x +1. So this right here is our fully factored form. Right? So we initially factored by grouping, but we got it down to our 2 factors. And we noticed that one of them was a difference of perfect squares, so we could factor it further. All right. I want to say, so if I'm pretty sure that I changed some settings on here that if I am teaching, I don't see them. Maybe you guys see them. There should be something on here where if you guys are good with something, you can put a thumbs up, or you can tell me to slow down, or if you just want to put it in chat, you can do that as well. But if I'm here teaching live, okay, and you got a question, just feel free to speak up. Just, you can message me privately, okay? You can send it just to me so the rest of the group doesn't want to know if you've got a question. Okay, or you can send the question to the group, okay? But for me, it's kind of hard to gauge the feel of the class if you guys are with me or not, right? So, okay, so this last section, factoring trinomials. So there are lots of methods to factoring trinomials, right? Typically, when a lot of you guys learned, you used like an X method, where here, if you have a leading coefficient of 1, you would put the 5 at the top and 6 in the bottom. You say what multiplies get 5 and adds to get 6, right? So you would have 5 and 1. So you'd factor it to x plus 5 and x plus 1, okay? And that works perfectly when you have a coefficient of 1. It's when you get to other examples where you have leading coefficients other than 1 that it gets a little more tricky, and that's where you have all of these different methods. So you might do a slide and divide method. You might have a factor by grouping method. At this point, if those are one of the methods that you like, or if you want me to recap one of those, I can, but I just use a guess and check method. And so how that works, okay, is if I'm factoring out a quadratic, I put out my parentheses. I know the first terms in the parentheses, okay, have to be factors of 5x squared, meaning when I multiply these two, I have to get 5x squared, right? Now, this one's pretty simple because 5x squared or 5 is a prime number. So the only two numbers that I can use to multiply to get 5 are 5x and x. So I know that has to be true, okay? So next is where I have to split up 4. Okay, so I know factors of 4 are 1 and 4, or 2 and 2, okay? But where to put them and whether to make them negative or positive is where we guess and check. So I know that these two numbers have to multiply to get negative 4. But when I multiply my outer and my inner terms, they have to add together to get 1. And so that's what we're checking, okay? So I know that if I put 1 here and 4 here, my outer terms is 5x. My inner terms are 4x, okay? If I add those together, I get 9, or if I subtract them, I get 1. I'm looking for 1. So I'm gonna make this a positive 1 and a negative 4, right? So now my first terms give me 5x squared. My last terms give me negative 4. And if I combine my outer and my inner, the products of my outer and inner, I get that 1, okay? And that's how I like to do it, just mainly because, you know, I work with numbers. I can see that and I can visualize that. If you would like the process, the review of where you split the middle term or the slide and divide, after we're finished with this, hang on, and then we'll review those processes with you, okay? If you like a more step-by-step process rather than just kind of playing with numbers, okay? All right, so for C, 6x squared plus x minus 1. If I guess and check. So I'm going to use there could be two possibilities here, okay? We could, for those first terms, I could use 6x and x, or I could use 2x and 3x, right? Both of those are possibilities to get that 6x squared. I typically like to start with the factors in the middle, and then I work my way out. Okay, so I start with 2x and 3x, and I say, all right, the last terms have to multiply to get negative 1, okay? So one of them has to be positive 1, one of them has to be negative 1. That's the only option. But determining whether they go here or here, that, you know, who knows? That's what we'll figure out. So if I'm going to put a 1 and 1 here. So that's 2, that's 3. We're looking for a positive 1. Okay, so I want my larger number to be the positive, my smaller one to be the negative. So we get a negative 2x, a positive 3. That gives us what we're looking for. All right, so these are going to be my factors, and I didn't even need to look at this one. Okay. All right, questions so far? Okay, all right, last one. Now, this one is a trinomial. Some of you guys might go, oh my God, x to the fourth. Okay, this is what we call quadratic form. Okay, it's not necessarily a quadratic, or it's not a quadratic, it's a quartic, it's fourth degree, but it falls along those same rules as a quadratic would. So basically what we want to do is we're going to envision this as x squared minus 3x minus 10. We're going to factor it the same way. The only difference is that when I write my first terms, I'm going to put x squared, okay, instead of x, right? Because x to the fourth times x to the, or sorry, x to the second times x to the second is x to the fourth. And then when I multiply my outer and my inner by an integer, I'll still combine them to get that x squared, right? So we'll just use x squareds instead of x's when we have that x to the fourth. All right, so now here we can simply just say what numbers multiply to get negative 10 and add to get negative 3. Okay, so we get a negative 5 and a positive 2. Because these are still quadratics, if we want to check to see if there is another difference perfect squares like we had up here, we can, but 4, 5, and 2 are not perfect squares, so this is as far as we can factor. All right. Okay, so those were all the examples that I have. If you guys, like I said, if you would like to get a recap of the slide and divide or guessing or the split the middle term method, just kind of hang on. But I'm going to go ahead and let you guys go. There is an assignment just to get a little extra practice on factoring on Delta Math. Okay, I think I'm pretty sure. Let me double check that I labeled it correctly. Yeah, so it's number 2, factoring practice. And same thing as last one. For this one, there's no work submission. But whenever you finish, you're going to get on Canvas and just submit your score. Okay, so you don't need to submit a picture for the assignment for today, but when you finish the review, you'll just type whatever score that you got in. Right, and more often than not, it's going to be 100 just because you're allowed to keep working on those problems until you get them correct. Okay. Does anybody have any questions?
Nope.
All right. It was good to have you guys back. Hopefully I get to see you in person soon, but otherwise you guys have a good day and good luck with the rest of your classes.
Thank you,
Have a
sir.
nice day.
See you on
See ya.
Monday.
Thank you.
You're welcome.